Welcome students to the chapter number 4 of Engineering Materials, Heat Treatment of Steels, Part 1. Now, what is heat treatment? Heat treatment is defined as the method of obtaining desirable physical and mechanical properties in steel by heating the steel to a definite temperature and then cooling it at a suitable rate. Heat treatment may also be defined as an operation or combination of operations involving heating and cooling of a metal or alloy in solid state to obtain the desirable conditions, such as to relieve the stresses or to obtain desirable properties such as better machinability, improved ductility, homogeneous structure, etc. Purposes of heat treatment: to remove the internal stresses set up in a steel due to previous hot or cold working on it, to soften the steel which is hardened by the previous heat treatment, to harden a soft piece of steel, to improve machinability of steel, also to improve other mechanical and physical properties such as ductility, malleability, corrosion resistance, etc. To refine the grain size of the steel, to improve the electrical and magnetic properties of steel, and finally to change the composition of surface layers of steel. Iron-carbon equilibrium diagram. The iron-carbon equilibrium diagram is that diagram which indicates the transformation that occur in the structure of steel having compositions from pure iron to cementite, which contains maximum carbon percentage of 6.67%. It is so called because any point in the diagram shows iron-carbon alloy of definite composition which exists at a particular temperature. An equilibrium diagram is constructed by plotting temperature along the y-axis and percentage composition of alloy along the x-axis. This diagram shows ranges of temperatures and compositions within which the various phase changes are stable, and also the boundaries at which the phase changes occur. To go through the iron-carbon equilibrium diagram properly, we must have to know some important parameters. At first, we have to know lower critical point temperature. When a piece of steel is heated, gradually its temperature rises and an instant is reached from when the rate of rise of temperature is first arrested. This instant is called lower critical point, and the temperature at this instant is called lower critical point temperature. For any plain carbon steel, the lower critical point temperature is same and equal to 723 degrees centigrade irrespective of carbon percentage. Now, upper critical point temperature. If heating is continued, another instant is reached from when the rate of rise of temperature becomes the same as that before reaching the lower critical point. This instant is called the upper critical point and the temperature is called upper critical point temperature. Upper critical point temperature is different for different plain carbon steel depending upon the percentage of carbon present in the steel. Eutectoid steel. It is that steel which contains 0.8% of carbon and which consists of perlite only. The upper critical point temperature and the lower critical point temperature of eutectoid steel is the same and is equal to 723 degrees centigrade. Hypoeutectoid steel. Hypoeutectoid steel is that steel which contains less than 0.8% of carbon and consists of ferrite and perlite. Hypereutectoid steel. Hypereutectoid steel is that steel which contains more than 0.8% of carbon and consists of perlite and cementite. Utility of iron-carbon equilibrium diagram. Iron-carbon equilibrium diagram is very much important in understanding the basic principle of heat treatment of steel. We get the following important data from iron-carbon equilibrium diagram. The lower critical point temperature is the same and is equal to 723 degrees centigrade for any steel irrespective of carbon percentage. The upper critical point temperature is different for different steel having different percentage of carbon. Temperature at which a solid piece of steel will start melting and will finish melting. Possible change of structure which will occur when steel having definite percentage of carbon is heated to a definite temperature. Iron-carbon equilibrium diagram indicates the transformation that occurs in the structure of steel having definite percentage of carbon when the steel is heated to a definite temperature. This diagram is drawn for the steel from pure iron to cementite which contains 6.67% of carbon. Transformation during heating. When hypoeutectoid steel is heated above lower critical point in the diagram which is PSK line, at first the perlite is converted into austenite. When this steel is further heated above upper critical point in the diagram which is GS line, the remaining ferrite is also converted into austenite. For hypereutectoid steel, when It is heated above lower critical point, that is PSK line in the diagram. At first, the perlite is converted into austenite. When this steel is further heated above upper critical point in the diagram, which is AC line, the remaining cementite is also converted into austenite. Transformation during cooling. When austenite is cooled below lower critical point slowly, ferrite and coarse perlite will be formed for hypoeutectoid steel, and cementite and coarse perlite will be formed for hypereutectoid steel. An increased rate of cooling leads to formation of fine perlite known as sorbite. If the steel is cooled at a more higher rate, more fine perlite will be formed. This perlite is called trustite or bainite. If the steel is very quickly cooled, which is known as quenching, the austenite is decomposed into a new structure called martensite, which is a very hard substance and whose Brinell hardness number varies from 650 to 750. Part 1 of heat treatment of steel is now completed. We'll be back with part 2 very soon. Thank you for listening the lecture.